students, welcome back to this new session. In this session I am starting with the problems on Poisson's distribution. Okay, this problem I have collected it from model question paper. Okay, so here is the problem. Suppose 300 misprints are randomly distributed throughout the book of 500 pages. Find the probability that a given page contains exactly 3 misprints, less than 3 misprints, 4 or more misprints. Okay, so it's very simple. Solution. So to solve this, yes, see, the mean, we can find out the mean of misprints randomly distributed. See, 300 misprints are randomly distributed throughout the book of 500 pages. Okay, so the mean, the average of misprints throughout 500 pages we can work for. Okay, so the mean of that, and you know mean mu of, or the average of the misprints is given by small m. Okay, in the Poisson distribution you have seen that. Okay, so the mean of the misprints, I'll write the solution. Mean of the misprints in 500 pages is equal to 300 divided by 500, which is 3 by 5 or 0.6 you can say. Okay, so that mean is denoted by m, small m. I hope you remember Poisson's distribution. Yes, m, we take that m as 0.6. Okay, so the Poisson distribution we can write p of x is equal to e to the power minus m raised to x divided by x factorial, just check it. Okay, we have seen this. So this m we have found. This m is nothing but the mean of whatever the probability we are working for. Here I am considering the mean of the misprints in the 500 pages. It's given to be 300 divided by 500, which is 0.6. I can consider my mean average of the misprints, okay, to be 0.6. I hope the point is clear to you. Okay, now once this is done, yes, once this is done, you have, yes, this is equal to e to the power minus 0.6 raised to x divided by x factorial. You can write, substitute the value of m there. Okay, now we have to work for these problem, this fact. Okay, exactly 3 misprints. You have to work for exactly 3 misprints means p of x is equal to 3, the first part. So x denote the number of misprints here. X is number of misprints we can say. Okay, so the probability distribution p of x we have got this for this problem. Okay, so p of x is equal to 3, it will be e to the power minus 0.6 into m is 0.6 raised to 3 divided by 3 factorial. You have to work for this. E to the power minus 0.6, you can write it somewhere. Okay, I'll write it here. E to the power minus 0.6. E to the power minus 0.6 is 0.5488c. Just check it. Keep it one side. Okay, and so that you can directly write it 0.5488 into 0.6 raised to 3 divided by 3 factorial, which is 6, you will get. Okay, now when you further simplify this, it comes out to be 0.0197. Okay, so therefore the probability of exactly 3 misprints in a given page will be 0.0197. Okay, next the question says less than 3 misprints. So second one, less than 3 misprints. Less than 3 misprints means p of x less than 3. Okay, less than 3 misprints. So it will be equal to p of x is equal to 0 plus p of x is equal to 1 plus p of x is equal to 2. Not 3 over here. Okay, I hope the point is clear to you. Less than 3 misprints, it corresponds to no misprint at all in a given page. 1 misprint or 2 misprints, not more than that. Okay, so therefore p of, just put x is equal to 0, 1, 2, 3 in this expression for p of x, you will get the value. Okay, e to the power minus 0.6 raised to 0 divided by 0 factorial you'll get. You know 0 factorial is 1. Okay, now e to the power minus 0.6 into 0.6 raised to 1 divided by 1 factorial. 1 factorial is also 1. Next, e to the power minus 0.6, 0.6 raised to 2 divided by 2 factorial. 2 factorial is 2. Okay, now evaluate it. Now e to the power minus 0.6, 0.5488. This is 0.6 raised to 0, which is 1, divided by 0 factorial, it is also 1, plus 0.6 plus 0.6 whole square divided by 2 you get. If you simplify this further in your calci, it comes out to be 0.9748. Sorry, 0.97, you should get 68, 0.4768. Okay, just evaluate in your calci, you will get the answer. Finally, the last one, third one you are working for. The question says 4 or more misprints. 4 or more misprints means P of x greater than or equal to 4. This corresponds to 1 minus P of x less than 4, or it is 1 minus P of x is equal to 0 minus P of x is equal. This corresponds to, yes, I hope you get P of x greater than or equal to 4 means 1 minus P of x less than 4, or 1 minus P of x 0 minus P of x is equal to 1, P of x is equal to 2, and minus P of x is equal to 3. Okay, so if you continue it, you will get this to be, yes, 1 minus, what is P of x is equal to 0? You have just worked for that. Okay, just put the values here. Already, 1 minute, you have already worked for this. Okay, I can write it here. Take minus sign outside. Addition of this and this also, P of x is equal to 3 also we have worked. So addition of all these numbers is 0.9768. You have already solved. Plus P of x is equal to 3 is 0.0197. Put these values in your calculus. You will get this number to be 1 minus this will be 0.0003 4 or something you should be getting. Okay, just check that. Okay, this should be the final answer for this problem. Okay, I hope you have understood this problem. Continue in my next session with some more interesting problems. Okay, till then, thank you. Now let's continue with one more problem. In a certain factory turning out razor blades, there is a small probability of 1 divided by 500 for any blade to be defective. The blades are supplied in the packet of 10. Use Poisson distribution to calculate the approximate number of packets containing no defective, 1 defective, 2 defective blades in the consignment of 10,000 packets. I hope you have understood the question now. So let's solve this solution. See here, there is the probability of a defective blade. So let P, the P denote be the probability of defective blade. So defective is given to be 1 by 500 and that is 0.002. Yes, you get 0.002 as the small probability of a defective blade. Now, since given that in a packet of 10, the packets, yes, the blades are supplied in the packets of 10. So n is equal to 10 here. Now in Poisson distribution, you represent mean, the average of the defective blades I can find in the packet of 10 as n into P, which is 10 into 0.002, which is 0.02 you get. Okay, so which is m is equal to 0.02. Okay. Now once we have calculated the mean of the defective blade, yes, we can write the probability distribution P of x for the Poisson's distribution. For Poisson distribution, we have seen that P of x is m raised to x e to the power minus m divided by x factorial. So using this, we have got value of m as 0.02. So it is 0.02 raised to x e to the power minus 0.02 divided by x factorial. This is our probability distribution function for this problem, is it not? By Poisson's we get this. Okay, now let us work one by one. No defective. Let us work for P of x is equal to 0. If x is denoting here the number of defective blades, okay, x is denoting the number of defective blades, because P is the probability of considered to be the defective, probability of a defective blade. Okay, so therefore P of x is equal to 0. No defective means x is equal to 0. First one. Right, so P of x is equal to 0 means it will be 0.02 raised to 0 e to power minus 0.2 divided by 0 factorial. Its probability comes out to be 0.9802, because e to power minus 0.02 is 0.9802. We have evaluated the probability for a non-defective blade. Now we have to find out the approximate number of those non-defective blades in the packets of 10,000. Okay, so therefore to estimate the number we have to multiply this probability with this 10,000 so as to get the number. So therefore it will be 10,000 into P of x is equal to 0. That will give you 10,000 into 0.9802, or which is equal to 9,802 number of packets containing no defective blades. Okay, yes. Now next one, second one, one defective blade. The next question is one defective. So let's continue for one defective blade. So once again you have to work for P of x is equal to 1 and multiply it by 10,000. Okay, so you will get that to be, directly we can work for that. Okay, since you note one more point here, e to power minus 0.02, it is equal to 0.9802. This number you evaluate and keep it aside so that it will be easy for you. Okay, now yes, so it will be P of x is equal to 1, because one defective blade means it refers to that. So it will be 0.02 into 1 raised to 1. E to power 0.02 is 0.9802 divided by 1 factorial. This you have to evaluate. Okay, you get a certain number. P of x is equal to 1 is this. Now since the question is been asked for 10,000 packets, I am directly going to multiply this number by 10,000. Okay, so directly we'll do it here. 10,000 into P of x is equal to 1. It will give you 0.02, or sorry, 10,000 into 0.02 raised to 1 is 0.02 only, and 0.9802. Just keep all the numbers divided by 1 factorial. 1 factorial is 1. So evaluate this. This number comes out to be 196. 196. Just check it. Okay, all of you. Similarly, let's go for the last one. 2 defective blades means x is equal to 2. So it will be 0.02 raised to 2 into e to power minus 0.02 is 0.9802 divided by 2 factorial is 2 only. So now this number I have to multiply it by 10,000 to estimate the number of 2 defective blades in the packets. Okay, so therefore 10,000 into P of x is equal to 2 we have to do. So it will be 10,000 into 0.02 whole square into 0.9802 divided by 2 factorial is 2 only. So if you find out that number, that approximate number comes out to be 2. Okay, so there are 2 such packets in the consignment of 10,000. So has, yes, the probability that there is, yes, there are 2 such packets where there is 2 defective blades. Okay, so you have all this. Okay, we have estimated the numbers. This was the question. I hope the problem is clear to all of you. Okay, if you still have any doubts, you can ask me in the WhatsApp group. Thank you. Now let's continue with one more problem. A shop has 4 diesel generators which it hires every day. The demand of the generator on an average is a Poisson variate. On an average is a Poisson variate with the value 5/2, means m is equal to 5/2. It's got here. Obtain the probability that on a particular day there was no demand. Okay, means x is equal to, if I say that x is the demand, number of demands, if I say, Yes. So x, you have to work for, there was no demand means x is equal to 0, you can solve. I'll let you know about that. Okay, a demand had to be refused. You have to work for what a demand had to be refused. When the demand had to be refused? When all the diesel generators are been already hired and another person comes for the same, with the same demand of the generator, then obviously the person had to refuse the demand. Okay, so let's solve this. It's very simple. It's given that the mean value is given to you. The mean value follows the Poisson variate. So m is equal to 5/2. It's given to you. Okay, so if it is given, the Poisson distribution P of x is equal to m to the power x e to power minus m divided by x factorial. So accordingly, it will be 5/2 raised to x. Now 5/2 is 2.5. Is it not? I'll write it here. It's 2.5. So 2.5 raised to x e to power minus 2.5 divided by x factorial. This is our P of x, where x is denoting the demand for the generators. Okay, because demand is following the Poisson variate, so I can relate my x to the demand of the generators. Okay, so now the first part of it says there was no demand on a particular day. No demand on a particular day refers to x is equal to 0. Yes or no? Therefore, first one, no demand refers to x is equal to 0. Therefore, probability of x is equal to 0 you have to work for. Just put x is equal to 0 in this Poisson distribution. So it will be 2.5 raised to 0 e to power minus 2.5 divided by 0 factorial. Now if you substitute all these values in your calc, you will end up with 0.08208. So this is the value for no demand. Okay, on a particular day, that probability that there is no demand, it will be 0.08208. Okay, so similarly the second part, the demand had to be refused. The demand had to be refused. Yes, it means what? Already all 4 generators were already hired. Yes or no? Then another person had to come for the with the same demand, and the person had to refuse the demand. Is it not? So therefore, if I'll write here, if the demand had to be refused, there should have been a demand, for more than 4 generators, because already the generators were 4 in the shop. So more than 4 means it cannot go for that, is it not? Because of the maximum number of generators itself is 4, right, in the shop. Therefore, you have to work for P of x greater than 4, which is equal to 1 minus P of x less than 4. You can easily work for that. P of x less than or equal to 4. Okay, so just work for this. It's very easy. So therefore, P of x greater than 4 is equal to 1 minus P of x is equal to 0 minus P plus P of x is equal to 1 plus P of x is equal to 2 plus P of x is equal to 3 plus P of x is equal to 4. Okay, just do this like how we have done before. So it will be 1 minus P of x is equal to 0. We have already solved 0.08208. I'll directly write the value here. P of x is equal to 1. I'll substitute the values and we'll evaluate using our calc. Okay, so you also do the same thing. P of x is equal to 1 means 2.5 raised to 1 e to power minus 2.5 divided by 1 factorial plus 2.5 whole square e to power minus 2.5 divided by 2 factorial, which is 2 again. I'm not going to write the factorials because already you know the values very well. Okay, so 2.5 whole cube e to power minus 2.5 divided by 3 factorial is 6 plus 2.5 to the power 4 e to power minus 2.5 divided by 4 factorial you will get, which is 24. So use your calci and evaluate it. The answer comes out to be 0.10882. Just check the value in your calci. Okay. So this is the complete solution for this problem. If you still have any doubt regarding this, you can always ask me in my WhatsApp group. Okay. Thank you till then.